हेलो ऑल ऑफ यू, वेलकम बैक टू दिस यूट्यूब चैनल। आज हम इसी वीडियो पे देखेंगे यंग्स मॉड्यूलस व्हिच इज डिनोटेड एज ई। सो व्हाट इज द यंग्स मॉड्यूलस? यू कैन सी हियर it is a material property that describe its stiffness or the resistance to deformation under stress। तो जब एक बॉडी पे जो स्ट्रेस होता है तो ड्यू टू दैट स्ट्रेस व्हाट विल बी द स्टिफनेस एंड द डिफॉर्मेशन that can described by the Young's modulus E, and it is defined as the slope of stress strain curve in linear elastic region up to the proportional limit. So we have, you can see this diagram. This is the stress strain diagram of mild steel, and this is the x-axis which can represent the strain, and this is the y-axis which can represent the stress sigma. So here you can see for a mild steel the stress strain diagram is like this. So O to A is the linear region. It is also known as the proportional limit O to A, and A to B is the elastic region, and D to is the perfect plastic region or yielding region, we can say. And again E to F, this region is known as strain hardening region, and again F to G is the necking region. So here in Young's modulus E, we are just going to discuss about O to A, that is the linear region. Means here in this body, this is the linear region, and we can say this is the proportional limit. So what is the main importance of this proportional limit? So the main thing is here Hooke's law is valid. So for Young's modulus E, we can say it is defined as the slope of its stress and strain curve in linear elastic region. This is the linear elastic region. Here the linear behavior occurs between the stress and strain. How to describe this? So if this is a linear region, so what happens in this proportional limit? You can see here the slope is constant. Here we can write slope is constant. Okay, so what is the slope? Slope means you can see this is the strain line and this is the stress line. This is x-axis is the strain line and this is the stress line. Again this strain and this stress line. So what happens? This is an angle theta 1. This is the angle theta 2. If the body behaves linearly, O to A behaves as like linear behavior or the proportional limit, means यहाँ पर हम कह सकते हैं यहाँ पर हमारा strain आ गया, this is the strain and this is the stress, this is again strain and this is the stress. So slope is constant, means the angle theta 1 is equal to theta 2 is equal to theta 3 dot dot dot. So here you can see if the slope is constant, then we can say this O to A behaves like as a linear behavior, or we can say that is the proportional limit. I will draw this pattern here. You can see, okay, this is the theta and this is the epsilon strain and this is the sigma or stress. So when I am going to find out the tan theta of this figure, tan theta is equal to sigma by epsilon, means stress by strain. So we know that for a very small angle the tan theta is always theta is equal to sigma by epsilon. So theta we can write for very small angle tan theta equal to theta. Theta is also equal to the Young's modulus E is equal to sigma by epsilon. So therefore here sigma is equal to E into epsilon, or we can say this E is the Young's modulus constant. E is the Young's modulus constant. Okay, so here we can say this is the formula to find out the Young's modulus of a body, or we can say the stiffness and the resistance to deformation under the stress. So this is all about the Young's modulus. You can see in the next class we are going to discuss about the stress strain curve. So stay tuned. Thank you.